Today we are going to talk about the sum and difference identities. Today specifically our goal is to find exact values of trigonometric functions using the cosine sum and difference identities. We're not going to worry about too much at once. So these are the identities for a cosine. And again, we use these to find exact values. I want you to note that when you're looking at the formulas, when you're subtracting alpha minus beta, that's subtracting two angle measures. 30 minus 45, 60 minus 30. We're subtracting two angle measures. But in the equation, we do indeed add. It's not an error. It's not a typo. Same thing when we're adding two angle measures, whether it's 135 plus 60. In the equation, it's the opposite. We subtract. So now, why do we use these identities? So if I gave you the cosine of 75, you can't do that on the unit circle, so you would pick up your calculator and you'd get a decimal, a really ugly decimal. So we want exact values, so we need to use these difference and sum identities. We can't use a calculator if we want exact values. So let's talk about the cosine of 75 degrees. We want to start by finding two unit circle angles that add up or subtract to equal 75 degrees. In this case, 30 plus 45 will give you 75 degrees. Once we find those angle measures, we rewrite our equation. Instead of the cosine of 75 degrees, we do the cosine of 30 plus 45. That way, we can use our cosine sum formula. And that cosine sum formula says, if I take the cosine of alpha, which is 30 degrees, multiply it by the cosine of beta, which is 45 degrees, I have to use the opposite sign, and then I'm going to do the sine of alpha, sine of beta. So if I use this formula, I'll be able to get an exact value, because now, if you notice, I know what the cosine of 30 degrees is. The same with the sine of 30 degrees. And I'm using my unit circle values. Now, I want you to note, the cosine of 30 is radical 3 over 2. I am not going to write the cosine of radical 3 over 2. That is a very common error. What I am going to do, it's substitution, is erasing and replacing. I'm going to wipe out that whole trig function and replace it with the ratio. It's radical 3. The same thing with the sine. It's not the sine of 1/2. The function equals 1/2. Then I'm going to do the same thing with my 45 degree. I know them on my unit circle. I know that the cosine of 45 degrees is radical 2 over 2, and so is the sine. Once I substitute those values in, I can just use algebra. So I multiply across, and I get the square root of 3 times the square root of 2 is the square root of 6 over 4, minus the product of 1 times 2, which is radical 2, over 2 times 2, which is 4. My final answer should be one single fraction, not 2, which is the square root of 6 minus the square root of 2 over 4. So therefore, the cosine of 75 degrees has an exact value of the square root of 6 minus square root of 2 over 4. Not so bad. Now, we didn't have to use those two angle measures. We could have also used subtraction. So what two unit circle values would you choose in order to make 75 degrees by subtraction? You should have said 135 minus 60 will give you 75 degrees. So we're going to use those two values to rewrite. The cosine of 75 could also be written as 135 minus 60. And now I'm going to use my difference formula for cosine. I'm just looking straight off of my cheat sheet and I'm writing it down. I know this is alpha and I know this is beta. So I have the cosine of 135 times the cosine of 60 plus opposite signs. The sine of 135 times the sine of 60. Again, opposite signs. You always want to double, triple check that. That is one of the most common errors. So now let's talk about our unit circle values. Easy, real easy is the 60-degree angle. I'm going to use my chart and I'm going to fill in what I know. I know the cosine of 60 is 1/2. I know the sine of 60 is radical 3 over 2. And again, it's not the cosine of 1/2, it's just 1/2. Now I want to talk about the cosine of 135 and the sine of 135. It is indeed a 45-degree reference angle, but the thing is, 135 is in the second quadrant. So that makes the x term negative, and that makes the cosine negative. Again, because it's in the second quadrant. So now I'm just going to fill in what I know. It's negative radical 2 over 2. In quadrant 2, y is positive, so sine is positive. And then I'm going to multiply. I'm going to take my products. I'm going to add them together. So I get negative radical 2 over 4. And I get radical 6 over 4. When I simplify that, I get negative radical 2 plus radical 6 over 4. So therefore, the cosine of 75 degrees is negative radical 2 plus radical 6 over 4. Now you may be saying, hey, Miss O, last problem, we didn't get that. If I rearrange this and do a minus radical 2, instead of putting the negative 2 in the front, I get the same thing. No matter which way you do it, you get the same exact value. So now, sum and difference formulas can also be used when it's not just a number, when we have ratios. So we're going to use some right triangle trig in order to use the sum and difference formulas and find exact values. So this is what they look like. And at first glance, this is probably what's going on in your head. So when I'm solving these problems, I always have 2 steps. First step, simplify all your information. Organize it. Second step, use the sum and difference identities. So that's the first thing we're going to do. Break it down by angle measure. So the first thing I want to talk about is angle x. I'm going to highlight everything I've been given for angle x. I've been given an interval, and I've also been given a ratio. I'm going to start by listing the interval. 0 is less than x, which is less than pi over 2. This interval is referencing between this and this piece of a Cartesian plane. Basically, this is a fancy way of saying, hey, I just want quadrant 1 values. The second thing I know is that the sine of angle x is 4/5. That is part of the sum and difference identity. You do need the sine, but you also need the cosine. So, when in doubt, draw it out. Draw me a triangle in quadrant 1. This angle here is angle x. Sine is the ratio of the opposite to the hypotenuse. cosine is the ratio of the adjacent to the hypotenuse. So I know the hypotenuse, but I need to find the adjacent side length. You can use Pythagorean theorem to figure out what this side length is. Or you can say, hey, it's a Pythagorean triple. It's a 3, 4, 5 triangle. So the cosine is 3/5. Now, I'm going to need information for angle y for my sum and difference formula. So I'm going to highlight some of the things I know about angle y. I have an interval. This tells me where it's located. And I have a ratio. This tells me some of the side lengths of the triangles. I'm going to start by writing down my interval. Pi is less than y, which is less than 3 pi over 2. When in doubt, draw it out. Pi is 180 degrees. 3 pi over 2 is 270. I want this quadrant. So this is a fancy way of saying, oh, give me your ratio in quadrant 3. Now, quick note, quadrant 3, the x and y are both negative. So now I know the sine ratio. The sine of angle y is -5 over 13. Okay, well, sine is the opposite over the hypotenuse. And I make the hypotenuse positive because it's a radius in a circle. Radii are always positive. Now I need to know what the cosine of that angle is. I know it's the adjacent compared to the hypotenuse. You can use Pythagorean theorem, or you can say, hey, I know this is a Pythagorean triple. It's a 5, 12, 13. And it's negative in the third quadrant. So it's -12 over 13. That's step A. Seems like a lot of work, but step B is real quick and simple. So I just want you to note that right here, I just have all those ratios rewritten, nice, neat, and organized. I added tangent because in the future we'll be working with tangent identities. We don't need them today, but we will be working with them. All right, now we're just substituting. We're just erasing and replacing. I know some information about x. So the cosine of angle x and the sine of angle x, I have them. The sine of angle x is 4/5. And the cosine of angle x is 3/5. Now I'm going to fill in what I know about angle y. I have the sine and I have the cosine. I have the cosine and the sine. I know the sine is -5 13ths. I know the cosine is -12 13ths. From here on out, it's just algebra. We multiply and then subtract the products. Again, because it was addition, our formula is subtraction. It's always the opposite. So this first product is -36 over 65 minus second product is -20 over 65, and it simplifies to -36 plus 20 over 65, which is -16 over 65. Therefore, the cosine of x plus y with all that given information is the ratio of -16 to 65. So I have another example for you. I want you to try it. I have the notes for you on the Google Classroom. If you have any questions or concerns, please let me know.